Afternoon. After discussing some brake problems with different people over the past couple of weeks, I've been meaning to do this brake video for a while. Since my truck doesn't have a bed on it, all of the rear brake components are really easy to get to. So I thought I would do a quick video showing how some of this junk back here operates. Let's start with the rear service brakes. This line right here is your service line coming in from the treadle valve. It goes to this T, which is a load on the load sensing valve. It also continues on to your air brake protection valve, which goes back to rear glad hands. I'll cover more on that in a little bit. Anyway, load sensing valve is a mechanical pressure regulator. The more you load down the bed, the more you compress the suspension, which allows this lever to come upward. The more this lever comes upward, the greater percentage of air pressure from this side is felt on this side, to apply more brake force with a more heavily loaded vehicle. This line is the output line. It goes down to your primary braking system relay valve. The way these relays work, they are basically a remote controlled pressure regulator. They take pressure in this case this is primary air pressure input from the primary tank. Whatever pressure is applied to this port, it in turn applies to these outlet ports using that supply port as its source. These two output ports go down to your primary brake actuators, the service side of your brake actuators, and push the actuator rods, which push the wedges and apply your brakes. When you release pressure off this by letting off the treadle valve, this valve dumps air. There's an exhaust port on the bottom. It dumps air out of these ports to match pressure. So whatever pressure is here is felt here. The primary air flows on through an outlet port on the back side here. It comes up over the top, goes down to your inversion valve. That's your primary supply air to your inversion valve. And it goes on around to one side of a two-way check valve. This is primary air here in. The bottom one is air from the secondary tank, and whichever is greater provides the supply source for your anti-compounding valve. So the anti-compounding valve is what controls your air to your park spring compressor diaphragms down in your actuators. So your park air comes from the control valve up in the dash here, and it basically goes through the valve and comes out on this port. So same theory as the relay valve below. This one just has two inputs. Whatever pressure you apply here, this relay valve uses the source to apply that same pressure on the outlet. These two lines go down to compress your mechanical springs in your brake actuators to release your park brakes. Well, let's cover the anti-compounding valve first. Its purpose, the other line coming into the top of it is teed off of here, and it hops over and tees off of here. This other line that's teed is secondary service air from your treadle valve. So when you step on your treadle valve, this gets air pressure applied based on how hard you push on the pedal. What can happen is if you don't have park brakes, or if you have your parking brakes set, no park air, and your springs are compressing your actuators, and then you go ahead and step on the brakes, not only do you have spring pressure pushing on the actuator, you have however much service air pressure pressing on the diaphragm at the same time. That can be over 200 pounds of force being applied to the actuator. It can damage the wedges, it can damage the diaphragms inside the actuators. So what this purpose of the anti-compounding valve is to keep that from happening. So if you have park air applied, that's fine. The springs are compressed, not a problem. If you don't have park air applied and you step on the brakes, it applies secondary air to this port, which in turn sends air pressure equal to whatever you're stepping on the brakes, whatever the surface pressure is, down to compress the springs in the opposite direction so you don't damage your actuators or actuator rods or wedges. So that's its purpose in life. The inversion valve is designed to provide emergency braking. It senses primary air, and then it also senses secondary air from the treadle valve. If for some reason you start to lose primary air and you're not getting full primary braking force, you don't have full primary braking force available, what this valve will do will it'll vent parking air, and it will allow the springs to expand and apply braking force, just like if you were setting the parking brake, as you step on the pedal. So the more you step on the pedal, the more park air is vented, the more mechanical spring force. So it will give you, if you lose your primary brake system, it will give you reduced controlled braking using the park springs, at least until that air leaks away. Okay, the air brake protection valve. So it gets service air in, it gets emergency air from the trailer brake control, the red button on the dashboard, and then it outputs air to the rear glad hands. There's one of the tubes here, and here's the other one right down here. What its purpose is to allow a air pressure to vent when you let off the brake pedal. There's a vent on it to allow it to dump air to keep it from back feeding into your brake system from the trailer. What it also does is it also provides some flow limiting. If for some reason you have a leak in the trailer, you don't want all of your service brake air to escape out through the trailer and deny your vehicle of brakes as well. So like the pressure protection valve on the wet tank, this valve limits the amount of flow. So if the trailer is drawing too much air, it will cut off that flow to protect your vehicle brakes. That's about it. Anyway, any questions, leave a comment. Have a good day.